Okay, 8th graders, today we are going to do section 4.4 and we're going to talk about scientific notation. So a couple of terms, and you guys, I know you saw this as 7th graders too if you had me, but the first term is scientific notation. Scientific notation is just a way to express very large, not larger, or small numbers. And standard notation is the normal way we express numbers. Okay, scientific notation has a number and it's times 10 with an exponent. There's a couple of rules that this number has to be greater than 1 but less than 10. So notice these are all 3.12, 1.35, 2.7, 2.0. We cannot have a number that would be like this, 32 times 10 to the 6th. That's not in scientific notation because 32 is greater than 10. So we want to take these scientific notation numbers and we want to express them in standard notation. And so what we are going to do is we're going to move the decimal point. If it's a positive exponent, it goes to the right. It makes it larger. So we start with 3.12, and then I am going to move that 9 places. 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, I might have done too many. 1, 2, 3, 4, 5, 6, 7. I'm getting a little pen happy today. So, because the 1 and the 2 took 2 places, I know that there's 7 zeros. 1, 2, 3, 4, 5, 6, 7. And then you throw your commas in there so we can read the answer. So with a negative exponent, what's going to happen is it's going to make it a small number. It's going to go to the left. So I have 1.35, and then it's going to move 4 places. 1, 2, 3, 4. And then the decimal point goes there, and I fill in the zeros. So our answer on this one is 0.123135. Negative exponents does not make it negative, it just makes it a small number. And then the next one, 1.35, same first number, but I have a positive exponent, so 1, 2, 3, 4, 5. Write your answer. Don't write it with all these loop-de-loos there. I want it written nicely so that I can tell what your answer is. Okay, so I want you guys to pause the video and do these 2 examples on your own, and then I will do them and you guys can compare your answers. So for the first one, you should have arrived at 0.0027, and for the second one, it would have been 0.000201. Both of them were small numbers because we had negative exponents. Notice neither one of my answers are negative. Okay, the next type of problem, we are going to take it from standard and we're going to put it into scientific notation. So the rules here is that the first number needs to be greater than 1, but less than 10. Okay, so we're going to move our decimal point, number of places we need to have. So 1, 2, 3, 4, 5, 6. I can't stop there because it's 0.3. It's not greater than 1. It would end right there. So I moved it 1, 2, 3, 4, 5, 6, 7 places. So this one just turns to be 3, times 10 to the 7th. And a lot of people are confused, well, this is a -7 or a +7. Well, I had a small number, that means it was a negative. The next problem, kind of think about where your decimal point is going to go. I know that it's going to go right here because it's going to be 7.09. It's greater than 1 but less than 10. 1, 2, 3. So I have 7.09 times 10 to the -3rd. Now I look at my next two examples and I know that they are going to be positive exponents. There is not a decimal point, but we assume that it's right here because they're whole numbers. So again, you still have to move it to make it a number that's greater than 1 but less than 10. So 1, 2, 3, 4, 5, 6. So this is 1.2 times 10 to the +6. And then this one is going to go 1, 2, 3, 4, 5, 6 also. So 4, but you have to add all those zeros. 1, 2, 3, 4, 5, and then the 1, because the 1 holds all those zeros in there. So just make sure you can't drop off numbers. Okay, on your own, why don't you guys do these two and then check to see if your answer is correct. Go ahead and pause the video. So this one you get 4.3 times 10 to the -1, 2, 3, 4, 5, 6, 7, 8, 9, -9th. And the last one there, you get 2.3 times 10 to the +4. Okay? So scientific notation is actually used a lot in science. Think of times when you're dealing with very small or very big numbers, like how far you are away from, a planet, or the size of a very small organism, those types of things. So it says a monarch butterfly has an average mass of 0.5 grams. In one roosting colony in Mexico, it was estimated that there were 10 million monarch butterflies. Write the total mass in scientific notation. So if each butterfly weighs half a gram and there are 10 million of them, we're going to have to do some multiplication. So 0.5 times 10 million. Okay, so if you think about it, 0.5 is half. So half times 10 million equals 5 million. And then we have to write that in scientific notation. So it's going to be 5 times 10 to the, and then we moved it 1, 2, 3, 4, 5, 6. And then it's a word problem, so make sure you label it. Okay, why don't you guys take a second and pause this one, and then you can compare your answer to mine. You would take the length of the pencil, and then you would multiply it times 10,000 because there are 10,000 pencils. And if you multiplied it, you get 187,000 centimeters, but the next catch is that it wants it to change it to millimeters. There are 10 millimeters in every centimeter. So we've got to add another 0 on there. And again, they want this in scientific notation. 1.87 times 10 to the 6th. Okay. The last kind of phase of this is they want you to be able to make comparisons. And comparing in scientific notation is actually very simple. Okay. If the numbers are the same, you go right to the exponents. So think of a number line here. Who is smaller? -7, -6, -5, -4, -3. This way is smaller. So the -7 is actually a smaller number. It's not negative, but it's smaller, so this guy is larger. You could expand these out and look at them, but you don't need to. The next one, if these are the same, then you look right at the numbers. So who's bigger, 6.3 or 5.3? And the 6.3 is bigger. So it just depends. Are the numbers the same or are the exponents the same? Last couple here, the major component of human red blood cells are white blood cells, platelets, and plasma. A typical red blood cell has a diameter of 7 times 10 to the negative 6 meters. A typical platelet has a diameter of 2.33 times 10 to the negative 6 meters, which has a greater diameter. Okay, so we're going to look here. They're the same. So then you go to here. Who's bigger, 2.3 or 7? And the 7 is bigger, and that's a red blood cell. Okay, and then the last one, why don't you guys pause this video and do this one on your own, and then you can start it again and compare your answer. This one says a certain cell has a diameter of approximately 4.11 times 10 to the negative 5th, and a second cell has a diameter of 1.5 times 10 to the negative 5th. They both have the same exponent, so they want to know what has a greater diameter. Who's bigger, 4.1 or 1.5? And it's the 4.1. So I don't know if you would say that's the first cell. Okay, and then just ask yourself, can you write a number in scientific notation? Can you write a number in standard notation if they give it to you in scientific? And can you compare? You should be able to do those things at the end of this lesson.